Good afternoon. My presentation is about REHVA ventilation guidance, and now we are just releasing already version number 4 of that guidance. So this is basically already to submit it our member associations and should be very soon available also on REHVA webpage. So I tried to highlight what has changed in our recommendations by this, the latest version. We have generally been giving about 15 recommendations for the existing buildings, which are basically quite easy, or let's say reasonably easy to address in existing buildings. That has been the idea of that guidance. And indeed, there is no time to go all of these through in very detailed fashion, but I try to do this for the main recommendations. So what we have been recommended from the beginning is to extend ventilation operation hours, switch on ventilation 2 hours before and keep it on 2 hours after the occupancy. And previously it was recommended not to switch off for the nighttime and weekends, but this is now has been changed so that ventilation can be switched off when there is no occupancy. And the reason is that no scientific evidence have been found against that. And indeed, winter is approaching, so this is also not so easy to keep systems running, and if there is no benefit, then this is not needed anymore. And the same applies for the toilet exhaust ventilation. This can be also operated in the same fashion as main air handling units, so can be switched off for the nighttime according to the new guidance. Then, as you know, there are many buildings where there are mechanical ventilation systems are not installed. And these buildings very typically rely on window opening, and when it is recommended indeed extensively to use windows for the airing, but to be sure that air change is adequate, we are recommending to install to the classrooms, open plan offices or meeting rooms, small CO2 sensors, just to be able to monitor the availability of outdoor air ventilation. And because of epidemic condition, we recommend lower values than usually. So yellow light should be about 800 ppm and red light or alarm given at 1000 ppm. So in order to show that when the ventilation is not sufficient and when the window, somebody will need to open the window or leave from the room. So that's the guidance for the buildings where ventilation systems are not installed. We have one specific appendix about rotary heat recovery sections, and the question has been, are these heat recovery equipments carrying over any possible virus particles, or are they safe to operate? And this very much depends on the leakages. If these systems are designed and operated in correct fashion, then the leakage should be very small, no more than 2%, but if there is higher pressure on the exhaust side, then indeed it can generate very high leakage, and this is not acceptable. So basically we suggest that it is safe to operate heat recovery, but we recommend to conduct inspection of the condition of these heat recovery devices. And as you can see, this inspection procedure will include pressure measurements, where should be always positive pressure from supply side to exhaust side if fans are correctly in correct positions installed. And another recommendation is to take a temperature measurements of these 4 air streams, and when the rotor is stopped, then this temperature measurements will show in very easy fashion what is the leakage in these rotors. So this type of a procedure has been developed. It's quite easy to inspect this equipment, and when it is easy to assess can it be safely operated or not. Then very general recommendation indeed is not to use recirculation in air handling units because of cross-contamination from exhaust side to the supply side. In the situations when, because of heating capacity or cooling capacity, it would not be possible to switch over completely to outdoor air, when we provide 3 options how to improve the situation. So in theory, one would need HEPA filters to remove all particles, so HEPA filters in the return air side, but this is usually not possible to install to the existing system. So minimum improvement we are recommending is replacement of existing low efficiency return air filter with EPM1 80% efficiency filter, so what formerly was called as F8 class filters. That's the minimum recommendation and should be, let's say, reasonable improvement in many cases. Why we are recommending these EPM 80% filters? Because the virus indeed is very small. It's about 0.1 micrometer, but it's never naked. And when one will check what is particle droplet size distribution expelled by a human being, then we will see that these are mainly in the range from 1 micrometer to 10, where is practically the maximum of these expelled droplets. And larger than 1 micrometer are already quite easy to be filtered, and this is the reason we are recommending such not too good filter for the return air. When we previously had a recommendation also for room level circulation, that means split units, fan coils, also induction units, but no evidence has been found that these units will cause any problem, and currently we recommend that it is very important in the case of fan coils and split units to be sure that rooms have enough outdoor air ventilation, and this needs to be organized either by mechanical means or by window airing, and we have dropped the recommendation to keep fans of the fan coils continuously in operation, so this is not anymore required. But we have had a general precaution about the high air velocities, especially because they might be directed from one person to another person, and this is something what needs to be avoided. And if necessary, some room arrangements might be needed if there are very strong targeted air velocities by these devices. So this recommendation is also one major change in our version 4 guidance. We have also provided some recommendations about the air cleaners, and it's important that they have enough capacity. So airflow rate capacity needs to be at least 2 air changes per hour calculated with a room volume. and it is recommended to go up to 5 air changes per hour to use a higher capacity devices. So when complete new part, what has been added to our guidance is for the risk assessment. And when we speak about ventilation, when this exposure is, it depends on the concentration, so the dose equals concentration multiplied by breathing rate and also time. So two things we can most easily affect is the virus concentration in the air by ventilation and then indeed occupancy time. And what happens even in well-ventilated rooms, it's very important to keep this physical distance, so about 1.5 meters, because general ventilation will not remove the source, but it very well will dilute this source and indeed will remove these all particles from the room. So that concentration is much more lower compared to the situation if ventilation is not on or ventilation is less effective. And what we know about this disease today is that there is two types of infections that are the most common. So these typically have been happened in the close proximity, for which, yes, general ventilation is not the solution. And another typical case has been just rooms which do not have ventilation at all. So there are reported such cases where only 1 or 2 liters per second ventilation. So this is basically 10 times less than it should be from some reported cases. And for, let's say, these common ventilation rates recommended by existing standards, there is no good evidence available, is this enough or not, but some evidence for the very high ventilation, basically we have in hospitals. And also, for instance, in the meeting rooms and classrooms, we can have very high ventilation rate, about 5 air changes per hour in already typical buildings well ventilated today. And very recently, WHO started to speak about 6 air changes per rate, what is something like a safe ventilation rate. For this assessment, we have provided Wells-Riley type of calculation, and then the source strength is very important, and the latest data published for this SARS-CoV-2 virus is also reported, and this can be compared. It's close, for example, with common cold, where the magnitude is quite the same in these quanta units. So quanta is defined as a dose. If one will get this dose, infection risk is 63%. And this is very simple equation that then can be applied to calculate different rooms, and such calculation examples, for instance, here for 8 hours have been provided, and we can see that in some rooms risk is very high, much more than 5%, which perhaps could be seen as some sort of a reasonable level, and in some spaces it is quite low. For instance, open plan office not well ventilated below the standards when the risk is higher, but open plan office 2 liters per second per square meter, when this will be less than 5% infection probability. And it is very interesting to see that in the classrooms, even with quite different ventilation rates, infection risk probabilities are pretty low. And the highest curve in this figure is a small office room occupied by 2 persons. So in small office rooms, if there is 1 infected person, as assumed here, then indeed it's almost impossible to avoid this infection. There is no such ventilation capacity available. And this can be also shown as a relative risk. In terms of a relative risk, also showing the effect of category 1 level ventilation compared to common indoor category 2, and indeed category 1 ventilation rates will improve the situation. So to conclude, indeed in buildings there are many possibilities how to improve ventilation solution, especially in the future. General ventilation can be improved, personal ventilation solutions can be applied, but already many buildings today can be used in quite a safe fashion if this type of risk assessment would be conducted, and then it would be possible to see in which rooms how long occupancy could be reasonable. And basically the situation is so that more ventilation is always better, but to dilute this aerosol concentration, the total airflow rate per infected person, this is the important airflow rate what really matters, and this will dilute the concentration. So it means that large spaces ventilated according to the current standards are reasonably safe, but small rooms, even if well ventilated but occupied by a couple of people, then these pose a high risk, and indeed only solution seems to be just to limit the number of occupants in these small rooms. And for future buildings and improvements, evidently this category 1 ventilation rates can be recommended because these provide already significant risk reduction compared to common category 2, what has been used as the most common so far. Thanks. That's all from my presentation.